Okay, for this problem, worksheet number 6, number 1. When I was a youngster up in Alaska, I'd climb the bluff, take a rock and throw it out, and take another rock and chase it, try and hit it. It's not so easy to do, by the way. For this problem, we're going to allow the first rock to just drop, free fall, and a second later, throw the second rock, which hits the first one 50 meters down. So this is all vertical motion, just to simplify a little bit. So the question is, how fast do I have to throw the second rock? All right, it sounds like a pretty good problem. I'm going to draw the bluff like this. There it is. And somewhere down here at 50 meters down, rock number 2 hits rock number 1. I'm going to call this position 1 here. This is position 2. All right, just for clarity. And so the deal is that this chaser rock has 1 second less time. Chaser rock reaches 50 meters in 1 second less time. That's a key thing. All right. So what we're going to do then is allow the first rock to free fall. We're going to let it free fall 50 meters. How much time does that take? Well, whatever that time is, this rock, the second rock, will have 1 less second than that to reach this position. So we can say h is equal to 1/2 gt squared, which then enables us to solve for the time. The time down is the square root of 2h over g, which is the square root of 50 times 2, 100, right, divided by 9.8. And that should give us 3.19 seconds. Therefore, rock number 2 T down is equal to 2.19 seconds. That's how much time it has to reach that position. So, rock number 2, and that's actually this one here, number 2, number 1, okay? Positions 1 and 2. So rock number 2, I'm going to set the position equal to the initial position plus Vy0t minus 1/2 gt squared, equation 5, where t is equal to this time. So that's really nice. We already know what the time is. So let's go ahead and put the values in here. The position, minus 50. Y0 equals 0. Y is equal to minus 50. Okay? That's how I set these problems up. Initial position equal to 0. So minus 50 is equal to y0, and y0 is 0, plus Vy0t, and this is what we're trying to find, okay, minus 1/2 gt squared. I'll go ahead and say minus 4.9 t squared. I am now using g is equal to 9.8 rather than 10, so that can affect the final answer a little bit if you use 10. All right, and so Vy0, which we're trying to find, is equal to, well, we can bring this out, 4.9 t squared minus 50 all over t. All right, so let's go ahead and plug that in. 4.9 times, all right, we have t, which is 2.19, 2.19 squared minus 50 over 2.19 is equal to, let me just see, 4.9 times 50 x squared minus 50, enter, divided by 2.19 gives you 5.5, something's wrong there. I have, oh, no. Okay, I have 5.5 times 10 to the third. Something's really funny. All right. Oh, calculator had a previous result in there. Sorry about that. 4.9 times 2.19 x squared minus 50, enter, divided by 2.19, enter. This looks better. This is equal to 12.1 meters per second, and that is the answer to the problem. Vertical speed. Whoops, I'm going off the page there.